I apologize for that. But what I wanted to do is I wanted to go from the basic, and then yeah, if it's fine, then probably we might have another session for getting into more advanced level. So what I'm going to cover here is basically what is required, what is AI, what is required for AI, and what are all the subsets of AI. When I say subsets, that's machine learning, deep learning, and generative AI, and how they contribute to AI. So what I feel that uh, a lot of things with AI now are already developed. Like there are a lot of models, so there are a lot of work. I think that's already been taken care by agents. For example, we used to write code previously. Now we have different AI tools like Cursor, right? And you just do that from the natural language perspective, and it builds the code. So currently, everybody is consuming the AI. But what I feel is you need to know the structure of AI or the foundation of AI, then you'll be able to appreciate it better, rather like not only when you're consuming that. So for that, we'll have to know the foundations, like what is machine learning, what is deep learning, and what is generative AI. Now the agents is the next thing, right? So we'll go with the the machine learning and deep learning and generative AI for this session. So now what is artificial intelligence? So artificial intelligence itself is made up of machine learning, deep learning, and generative AI. So when we first started artificial intelligence, we know about machine learning. So what is machine learning? You train a machine, or you train sorry. Okay,
You carry on,
Sorry, can you share
Aslam
your
bhai. We will
screen as
take care of the
well,
question. If
so
there are
that
any
because
questions,
you
they
will
will
be
be in the chat,
presenting.
and we will take care of that. You can carry on.
Okay. So when we say machine learning, initially it started with a subset of small sets of data, which we trained, we train a system, and the system was able to predict. Sorry. And the system was able to predict the data, right? Now that's called machine learning. I'll get into what are details of machine learning. Then came the deep learning. Why? Because machine learning was not able to handle large set of data, right? Because there are certain algorithms that are being used for machine learning, but when the data became huge, very huge, then machine learning was not capable of handling large data set. So that's when the deep learning came into picture, and the deep learning solved a lot of problems from image identification, right? Object identification. So the deep learning and self-driving cars. So these were solved by deep learning. And then came generative AI. So once we got deep learning, so both machine learning and deep learning are kind of analysis, and then it analyzes and it stores the analyzed result. But with generative AI, it started creating content based on this analysis, right? When I say generative AI, like ChatGPT, when we say ChatGPT, it's whatever you type in, it gives you answer back. So it starts creating content. It creates content. It creates content in text. It creates content in video. It creates content in images. So that's the next level. Like it went to generative AI. I've not included agents, but I'll just touch upon it. So now there is also a lot of talk about agentic AI. What is agentic AI? So now there are agents which does our job. So for example, I want to now from the chat GPT, I just type something and it gives me an answer. Now I just have to, I don't know, I will read that and say, okay, maybe this is not the answer that I need, and then I will rephrase my prompt. So I'll rephrase it multiple times in order to get my correct answer. With agentic AI, we have an agent called orchestrator, and then we have multiple sub-agents. So this orchestrator agent sends, so whenever we put in the request to the orchestrator agent, it gets the context and it calls the correct sub agent in order to get the answer. Now the orchestrator gets the answer, then it sees whether it is satisfied and whether it's satisfied with the answer. If it's not satisfied, it's again going to send that with a different prompt to the subagent. So it does that recursively or in a loop until it thinks that, okay, now I have the proper answer, and then it sends to us. So there's one additional layer that's been added between the human and the subagents. That's the orchestra agent, which takes care. So that it's called like reasoning it out. So there are different kinds of prompts. When we say prompts, so chain of thoughts and then reasoning, right? Chain of thought. Whenever we type something, the agent splits that into different steps. So if I say, okay, book a ticket, book an airline ticket, then it splits that task. So then it says like, what is the date, what is the destination, how many people. So it splits into that, and then it answers accordingly. So now there is the reasoning built on top of it. So this orchestra agent always reasons out to see whether the results written by the subagents are correct. Right. So that's the agentic AI. Okay. Now we'll go in in detail about machine learning. So what's machine learning? It's so I there may be programmers here, right? So previously we used to program. So we used to write a function, and whenever there's a function, we give a input, output, and then on the function we write a rule, like what it has to do. For example, if it's an addition, we write the rule, like how it should do, right? But now, what's the difference in machine learning is you train the machine, you train the machine, meaning you give the input, also the output, and you train it. You give large number of data and you train the machine. Now it learns a pattern. And now it will, so that's called so far.
No, I think
Okay.
we haven't received any questions, so
Okay, sure.
you can
So
continue.
now, I, probably I think it's very basic maybe. So what are the pillars of machine learning? I'd say so. We have supervised machine learning, unsupervised, and reinforcement. So supervised machine learning is kind of, we say, labeled data. So I said previously, like we give the question and then we give the answer and then we train it. So that's called labeling a data. For example, if I take flowers, right? So I can say, okay, this if the petal is of this color and if the petal is of this type, uh, then it is rose, right? And then so rose here is a label. So we identify based on those color and the characters of the petals, we identify that it is a rose. So that's called supervised, where we have when we say the color and the petal properties, right? So that we call it as features in machine language terms. And then rows, that which identifies the flower, that is called the label. So we have features and we have label. So we give the features and label to the system, so it identifies. Okay, then next time when you give a property of rose and then the properties of, I mean, color of pink and then the other properties of rose, it will automatically identify it as a rose, right? So that's called supervised learning. Unsupervised learning, it is, so you don't know what's the label, but there will be some kind of a pattern. So based on the pattern, it will be grouping people, or it will create some groups, right? So based on that, based on the pattern, it's learning. So that's called unsupervised learning. Reinforcement learning, it's learning through trial and error. For example, if you're creating a chess game, right? For every wrong move, you give a penalty point. You give a penalty point. So now the system knows, okay, this is a wrong move. If I do this, then I'm going to be penalized. So it learns. So that is the other move is not correct, right? So that's called reinforcement learning. So again, so this supervised, the supervised category is further divided into two types. One is called classification, one is called regression. So what is classification? So we all know, like, classification is classifying different data. When we say, so this also have subtypes like binary classification. Binary classification is yes or no. For example, if you see the example like spam filter, we know either it can be a spam or it cannot be a spam. It's 0 or 1. So that's called binary classification. And then we have multi-class classification. So this predicts one class from 3 or more possible options. For example, like if I give an image of a dog, if I give an image of a dog, cat, and a bird, it will identify, for example, whether it's a dog or it's a cat or it's a bird. Okay, so that's called multi-class. So out of many classes, we can still identify whether it's a dog or it's a cat. Okay, so that's called multi-class, right? So out of many classes, the previous one, it was just 0 or 1, but here you can identify, so that's called multi-bird, right? So now there is another thing called multi-label classification. So when we say multi-label classification, so for example, I have a document, and the document might have many contexts. Like it can have context of finance, it can have context of technology, it can have context of many politics, maybe. For example, if I have a document for technology might have some ERP software. So it might have something about the technology, it might have something about the finance, right? So that's called multi-label classification. So these are some of the classifications for supervised learning. And then we have something called regression. What is regression? Regression is continuous values. For example, I want to predict my stock prices, right? So I want to predict my stock price for next day, like today. Or I want to predict the house prices based on certain criteria, right? So those are all like continuous. So those are called regression. So again, the supervised learning is further divided into two sets of two types. I would call it two types: classification and regression. So why we have to do this classification, or why we have to do this categorization, like classification and regression, is because the model that we are going to use in order to train this will depend on this. Like if I have classification, then I'm going to use a certain set of algorithms. If it is going to be regression, then I'm going to use the set of algorithms. So it's actually very important to decide from the data we have to first, it will be like a starting point, even before we choose what algorithm we have to use in order to train the data. We need to learn about the data, right? And then this data, so this, we have to see where it falls, and then it will help us to choose the best algorithm to train the model, to train the data. So what's machine learning in daily life? Like email spam, recommendations, credit score and pricing. So these are all like whatever we see on our daily life. And now we have to get into deep learning. So I told what is machine learning. Before that, I wanted to tell something else. Give me a sec. Okay, I have not put that on the slide. So we say this machine is learning something, right? So what it is learning. And so when I say, for example, we have a linear equation, right? And for example, if you're using linear equation, or if you're using a linear model linear algorithm in order to train a model. So normally we say we say y equal to wx plus pi x, right? So there are two terms called, there are two important terms that we need to know. One is called weight and one is called bias. So whenever we are training a system, the system learns the weight and the bias. So it just learns the weight and the bias from the training data, and then it applies that into our data. I mean, the testing data or the data that it has not learned anything from, right? So if I have to give an analogy for that, so for example, I have, say we have to predict a salary, right? So the salary can be, how it can be calculated? By years of experience, right? And then there will be a bias. For example, if somebody has a zero experience, doesn't mean that they don't get any salary, right? So they have some kind of a starting point. So that's called bias. Hello?
Yes,
So
Aslam bhai, there is a question related to agentic AI. It says, Tapas is want to know that when we say AI chatbot went rogue in a higher level scenario, does it happen due to a presence of unsupervised data?
no, so that is called hallucination. So unsupervised, yeah. So when we say agentic AI, so that's kind of so that's a Gen AI thing. Okay, so generative AI. So what happens in generative AI is the way the data is being stored. For example, for generative AI, when I say how it is stored is, we take ChatGPT as an example. So ChatGPT gets trained on multiple words, right? Multiple sentences. So billions and billions of words and sentences it gets trained. And these are being stored in space. For example, if you take an Excel sheet, it's a row by column, right? It's a it's a one dimension, right? You have like rows and columns. But now with generative AI, it's the data that is stored we call that as a vector database, right? It's stored on multi dimensions. So there is X, Y, Z, and then there's a lot of other dimensions, which we cannot see in our naked eyes, right? So we cannot visualize in our naked eyes. So it's that much. Now, what happens is, since these are stored, now these are stored as numbers. If all the data is stored as number on this vector space, and so and that's why it is able to identify the synonyms. So currently, when we do a Google search, right? Not currently, previously, when we do a Google search, the search is by it's called lexical search, which is by the text. So it identifies by the text, and then there is a lot of other sorting algorithms and all, right? Like then it refines that. So it refines everything and it gives us the proper, the search. But now what happens is it doesn't, it's called semantic search. When we say semantic search, it searches by the synonyms, the meanings. For example, if I say something like happy, then the happy word is near to joy, all the synonyms, right? So what it does is it picks up all whatever is nearer to this happy word. It's called the cosine angle, so that's kind of an angle. So whichever angle is less, so it means those two words are similar, like it has a similar context or similar meaning. So it brings. Now what happens is, if I say, if there is a, and everything, whatever we are typing, it's kind of a stateless. So if I type river, the LLM should identify that whether it's a river bank. Sorry, when I say a bank, it has to identify whether it's a river bank or it's a financial bank. How does it identify? It identifies based on other following words, right? Now, when it is not able to identify this correctly, what it does is it starts hallucinating. Like it itself predicts some words and it will send us, right? That's why that's when it goes rogue, right? It's when it doesn't know anything, it doesn't say that I don't know, but it tries to put in its own intelligence and it brings up the data which will be totally out of context, right? So that's why you never believe what comes out of ChatGPT, right? You have to do your own due diligence before uh, believing those whatever is coming from ChatGPT. Mostly it will be right, but it still hallucinates. Again, there are ways to work around this, so probably that's all like too deep. Like we have something called a system prompt. So whenever we are creating an agent, there are two prompts. Which one is called a system prompt, one is called a user prompt. User prompt is what we type, and then we have a system prompt. In the system prompt, we can have certain guardrails. Now, these guardrails, when we say guardrails, like the security, like we say that, okay, be polite, stick to what that is asked for you. Do not hallucinate. If you say, if you don't know, say, I don't know. So these are some of the guardrails that we give on the system prompt that will make the agent less rogue. I hope I've answered your question.
Yes, Iftikhar bhai. Uh, thank you so much.
Okay.
It's a
Okay.
little bit clear now, but that's a much higher level of understanding, to go deeper. But continue. Thank you.
Okay. Nice. Okay, so coming back, so I was talking about the weight and the bias, which is the most important thing. And that is when we say that something, the machine is learning, it is learning the weight and the bias. So as I said, when we say salary, we say the years of experience, right? And then, if somebody has 0 years of experience, still they will learn something. So they'll have a starting point. So that is called bias. And the weight is, for example, now I have to decide on the salary based on my year of experience and my education, like whether I'm a postgraduate or a bachelor. Now, where do I put more weight? Like which? So I might have PhD, but I have less experience, and somebody else will have a bachelor degree, but they will have more experience. So where you will add more weight? So that's where the weight comes into picture. So weight into experience plus the weight into your education plus bias determines your predicted salary, right? So now for every 1 year experience increase, if the salary increases by 5,000, 5,000 is my weight, right? And similarly, for education, like if I have a postgraduate, then I might have I would give a weight of 1. I have two. If I have bachelor degree, I would give it as 1. So that's weight and bias. So what the system really reads is this weight and the bias. That's what is being applied to all the other, whenever we supply new data, this is what is being applied in order to calculate and come up with the predicted results. Okay. So yeah, I wanted to explain about the weight and the bias. Now we'll get into deep learning. So when I said we say machine learning, so machine learning, we have like supervised, unsupervised, and then the reinforcement. So yeah, and it has a set of algorithms that would work. For example, we have something called linear regression. So we have something called support vector mechanics. We have support vector regression. So, and then there are a lot of algorithms. We don't have to learn the algorithms now because all the algorithms are now packaged into uh, they are all packaged into Python as Python libraries, right? You have TensorFlows, you have support vector regression, everything is coming as a library. So it's kind of, we just have to, the main work that we have to do is cleanse the data and prepare the data for feeding into these different algorithms, right? So that's what our main challenge would be. Now, when we say machine learning, as I said, there are certain number of, so it can handle certain number of data, but it cannot handle large data set. So that's when we came into deep learning. So deep learning, it's a specialized form of machine learning that uses artificial neural networks, right? Like how our brain is connected. So how it works. So here, if you see, we have input layer, right? And then there is a lot of hidden. So there is this layers called hidden layers. So when we give the input is fed into different layers now. So it goes through these different layers and then it learns. So another thing that I forgot to say is uh, whenever we say that it's learning, or whenever we get some result from the machine learning, how we know that it's accurate.
No problem.
So none of the result can be 100% accurate. It can be 97. If it reaches above 90 itself, we say that okay, this is kind of that's kind of a good result, right? That whatever algorithm we have chosen and whatever data we have, that's all working perfectly. There are two terms here. We call that as overfitting, and we call as underfitting. So underfitting is, for example, I have multiple data, and the data is completely scattered around different. Oh, sorry. For when underfitting, I say that when I draw a straight line, all the data perfectly fits into a straight line. So that's called overfitting. It perfectly fits into that particular line. There can be Ideally, there can be no data that could just fit directly, I mean, in a straight line. If it fits directly in the straight line, it means that you are testing data. The data that you're using for testing doesn't have any outliers. Outliers in the sense there's all out like perfect, right? And when we do that, the testing might show us, while during the training, it will show us like 100% result, right? But when we are doing a testing, because when we do the testing with the data that we did not use that for training, right? Now when we use that testing data, then it will fail because it just learned only on the perfect training data. So that's called overfitting. Underfitting is like there's too much of scattered data, and it doesn't know, like we just simply put it as a straight line, right? Even though the data are scattered, we just say the machine language just says that everything falls in a straight line. So again, in that case, our testing data gets this called as overfitting and underfitting. Now coming to this, uh, now coming to here, the machine deep learning. So this deep learning, the data gets into each node, right? And then there's something called uh, back propagation. So it learns with the error. So when it goes to one node, as I said, it will assign weights and bias to different parameters. So there can be a lot of parameters, right, that we have as an input. For example, I can have, I'm training data with a population, right, population data set. So that will have the number of female, the number of male, number of children, and people in that particular area. So these are all, we call that as features, right? So when these are all the input that is being fed into these layers. So what it does is it assigns weight for each of these, it assigns weight for each of the feature, and then it travels to the next node. When it travels to the next node, uh, it will learn by the, so there is something called error, right? And when it travels to the next node, it will see what is the error percentage. If the error percentage is more, then it comes back and it reevaluates the weights and the bias, and again it sends to the next node, right? So that's how it goes to different nodes. Now we can decide how many nodes that it has to run. The more number of nodes it runs, that accurate result we will have. But the other caveat is the more number of nodes that we are going to have, we need to have that much compute power. So our compute power should be more in order to get proper results. For example, if we have ChatGPT, we say that it has 7 billion parameters, right? What is a parameter? Parameter is nothing but the weight, right? So whenever it is going to different nodes, the weights are adjusted. The weights for each parameter or each feature is adjusted. So there are like 700 billion weights that has been added, right? And so it takes like huge computing power. That's why you'll not be able to do, or you'll not be able to create a large language model in any system, right? It needs lots and lots of computing power in order to learn such data. So ChatGPT is one kind of deep learning, and then it gives the output. The output is, again, as I said, it's the weight and the bias that it has learned for each of the data. Any question here so far? Okay. So what are all
Hello, guys. Yeah, do you have any questions? Since Aslam bhai is kind enough to take questions on a topic basis, feel free to, if you have any question, unmute your mic and ask the question, or you just write in the chat box, and we will ask the question on your behalf. Thank you. I think Aslam bhai, there is no question so far, so you can go ahead.
Yeah. Okay. Sure. So what are all different types of deep learning? So we have artificial neural network, we have convolution neural network, recurrent neural network, and transformers. Transformers are nothing but the ChatGPT, what we currently use. So that is, we call that as transformers. So the model or the way that it's being assigned is transformers. Uh, Where we use convolution neural network is when we want to identify images. So uh, this, for example, like if I go to the previous node, if I want to tell how the convolution network works based on this diagram, so you can send images. So images will be the input, right? And then the hidden layers now will. So what are images? Images are nothing but a matrix of. It's a value of matrices, right? Um, where you'll have different values representing uh, I think the layer, the darkness or the lightness, right? The pixels. So what these layers will do is the first layer will be able to identify all the edges, right? Based on the edges, it will be creating weights. So then some like the other node will be learning about the color or the pixel colors that is into this, right? Like the gray shade, those things. So somewhere like this, all the nodes will be learning different aspects of this image, and then it's all stored, like all the weights and bias are all stored. Next time when you input image, but it might be not the same. So you'll input the image of a person, but it may not be the same image that you trained, but it's a different image. When you input that, now again, the system is able to uh, categorize that, or it is able to break that. It will identify the edges. Will say like the color is a noise, right? So for example, I'm inputting my image, right? And it will try to learn about that image. It will try to map out all the edges, right? But it doesn't. The color is. It doesn't have to know about the color because my other photo might not have the same color in that. So color is a noise here. So it will take off the color, right? So it will take off the weight for the color. Next time when I'm passing my other photo with a different color, it will obviously maintain the weights for the edges, right? But it doesn't have to maintain that for the color. So and that's how it identifies, okay, the previous picture and the other picture that I have input, both are similar. That's how it knows, right? Based on that. So that's what convolution neural network does. And we have recurrent neural network. So recurrent neural network is almost similar to transformers. Like before transformers, we were using recurrent neural network. So for example, if I have a sentence that I need to, I mean, this river bank, if this river bank is looking good, right? So that is my sentence. For recurrent neural network, like each and every word has to uh, pass through the nodes, right? Like the hidden nodes that I showed previously in the previous image. So it has to pass through the hidden nodes, like all the words, in order for it to know that it is specifying we are talking about the river bank and not the financial bank. But with the when transformers was invented, it did not have, the whole word did not have to pass through the nodes. Each word, what happens is each word will get the relation between themselves. So at a single point of time. So that's why it is so fast, and it's faster than recurrent neural network. So when each word gets their meaning and gets their meaning towards the other word, so it says like river bank, then it immediately identifies we are talking about the river bank, and we are not talking about the financial bank. And it doesn't have to go, unlike all the word doesn't have to go through the nodes. Okay, machine learning was deep learning. So what's this? So machine learning is data performs well, as I said, with small and medium data set. And for machine learning, you can still use CPUs, right? So we have different, like we have CPU, we have GPU, and we have now, I think, TPU. So These are the computing powers. So as the data set is very grows, grows bigger, we need a lot of computing power. And this computing power comes from the CPUs and GPUs. So here we say the feature, again, the feature is whatever properties that explains a particular object. So those are all features, right? So uh, here humans can identify what are all the features, right? So basically it's telling that the labeled data, right? So for deep learning, hungry for massive amounts of data. So definitely for all the deep learning, we have to use GPUs and above. Feature extraction or automatic. When we say automatic, so that's when it passes through these nodes and it learns everything automatically based on the pattern, right? And this one is interpretability is often a black box. When you say black box, so we say this as hidden layers, right? So we don't know what is happening here. So that's a black box to us. We just define we just define the algorithm and we just define how many nodes it has to pass through, right? But the weights and bias are automatically calculated through the hidden layers, like how many hidden layers there are inside. As I said, as we have more number of hidden layers, we will be more accurate, but again, there will be more number of, the computing power might be more. So what does deep learning power perception? So we have computer vision, healthcare, and natural language, like voice assistants, what we are going to use. Okay. Now coming to the generative AI. So currently, yeah, we know that we are using LLMs heavily. We are using diffusion image and we have code and audio. So what is an LLM? So large language model, right? As I said. So currently we have LLM, and now we have something called as SLM, small language model. Example of good example of LLM is all the ChatGPT, Gemini, Grok, DeepSeek. So these are all examples of large language model. So when we say large language, as I said, like large language model, they are trained on a variety of linguistic items, right? Like words, sentences, and there can be different languages, right? So they are trained on a lot of items. Now, when I said, when we talked about machine learning, and then when we talked about deep learning, we saw that how I mean the data, the machine that is learned, it's all mathematical, right? And it's all weights and bias that it is learning, correct? With LLM, the way that these are being stored is totally different. So we call this as vector database. So we call something as vector database. So everybody should know, like everybody knows what is scalar and vector, right? So scalar doesn't have a direction, vector has direction. So now currently how we store when we think of storing a data, we think of it as a database. We think of rows and columns, right? So initially it was like rows and columns. Then came objects like unstructured data. So when we say structured data, it's like rows and columns. So there will be a row and then you will have columns like age, name, address, right? So, and then you will store everything as a row. Now, then there was like unstructured data, like the documents, they're not structured documents. So we have to store unstructured data, right? So that we store that as, we call that as a JSON object. But for LLM, we store it we store that as vector databases. So when we say vector databases, this is kind of what I say, like it's stored in space. It has multiple dimensions for storing the large language model. So when we put it on different dimensions, again, all the words that we do, all the words will be broken down into something called embeddings, right? So because the computer doesn't identify it by alphabets, so it is identifying everything based on numeric. So whenever I write a word, this word, I mean, whenever I write a sentence, this sentence is chunked. When we say chunk, when I say chunked, it's broken. So if I say jumped the fence, right? That's a sentence. Now it is broken, like it is broken. Each word is broken, and then they are given a numeric value, and then they are stored on the vector space when they are stored on the vector database. Now the fox is stored on the vector database. Similarly, if I write another sentence and if it has an animal, it will also be stored on the vector database. But the fox and the elephant will be nearer to each other than the word the or jump, right? Because these both are categorized as animals, so their similarities will be more than the word like jump to fox, right? So next time when I'm writing a word, then if it is about animals, if I say animals, give me all, so I will say, okay, give me all the uh, domestic animals or wild animals. Now, yes, Srinivas.
Sorry, Aslam bhai. There's one query regarding the vector DB. So Syed Riaz is asking, can we query
Hey,
a
Srini, you have
vector
a
DB?
question? Hello.
Oh God, I cannot unmute myself.
Hello.
Sorry, sir.
Aslam, can we query a vector database?
Sorry, what's that? Can you?
Is it possible to query a vector database?
No. Query in the sense like how you are querying the SQL server or something like that?
Yes.
No. So this is all semantic search, right? So when we say vector database, it's kind of a semantic search.
Okay. Okay. Thanks, Aslam.
Yeah. So there is something. So if you want to, currently there is a new database that's called a graph database. So when we say graph database, again, it again stores semantic. I mean, it stores graph nodes. So that's kind of coming up, but that you can query. But this one is kind of a semantic index. So why we cannot query here is because, for example, I'm writing this word sentence, right? The brown fox jumps the fence, right? Now, in order to store it into the vector database, I need to break this down into numerical values, right? Now, in order to break this down into numerical values, there are different models. Okay, so I can use different models in order to break this down and put it in the vector database. So now, if I have to, if I'm just trying to use another sentence, right? Then it also has to break down those words with the same model that I used to break the previous sentence, right? So that's when it gets the same meaning or the same references. Does that make sense?
Yes,
Clear?
Aslam. Yes. Yeah. It's clear. Yeah. Thank you.
Yeah. So that's how the LLMs. So that's how LLM is going to answer our question. So that's how LLM is going to identify like what we have, like whatever we type. For example, as I said, now I write different sentences there, or brown frog jumps the fence, or uh, the elephant ride was great, right? So Now it chunks everything and it stores. Now the fox and elephant are much similar than the other words. Now if I ask to the chatbot or the LLM, right? I will say, okay, let me know what are all the animals I specified before. It will just fetch all the animals from whatever animals have it has chunked and stored, right? And it will just be able to pull those information. So that is the semantic way, right? Because in lexical search, I have to type whether it won't identify animals with the fox or the elephant, right? Because for lexical, it is word search. But for vector search, it identifies animals with elephant or fox. That's the difference between the lexical search and the semantic search, and that's how the LLMs work. I think I'll have another session only for LLM, because that's kind of a notion we can just show how what is a graph. I mean, what's a vector database, and we'll, we will we can some like visualize or try to visualize how lot of data is stored in space. So here we see data is stored in space. It's all around us. It's all revolving around us, right? And how the data is similar is based on how nearly they are stored. For the synonyms, as I told, like elephant and fox, since they're animals, so their proximity, based on that, their proximity is nearer. Because when jump is a different word, right? Jump and play will be similar. So their proximity will be similar. So if I say something, if my question involves play, then it might bring jump as well. The LLM might bring jump as well, right? So that's the concept of vector database. And then we have this diffusion, that is image. So image is not, I would not say that it's as advanced as um, the NLP, natural language processing, like LLMs. Image is still improving, but I think they're like now Gemini has improved a lot on the images. What images is basically, it will read the image, it will read the image objects, and then it will try to get us answers, right? Next is code and audio. So code is, they've improved that to the next level, right? So for example, I can just show you something. So this is called Cursor AI. So if somebody who is very familiar with the development, they will know what is Visual Studio Code. And now this Cursor, they really call that as Visual Studio Code on steroids, right? So here, it's so platform agnostic. So if I go here, and then, sorry, if I put Control K, then right, give me code for in writing it in the natural language, right? So it just gives. I say so React. Give me, I'll put like, okay, for let's say Angular. So it's so easy. Like now you don't have to, it's like you can be language agnostic, right? Previously, we had to learn Java, you have to learn .NET, you have to learn Python, you have to learn JavaScript, you have to learn React or Angular. But now it's everything is uh, agnostic. You just type and then it gives us answer. Also, you can have, so I think there was an agent here somewhere. Yeah, so you can chat with the agent, right? Like you can chat on give me best for coding. So it's all completely integrated here. So this is the code part of AI, right? And now we have GitHub Copilot. So GitHub Copilot, it has its own, it has all the actions. So when we do some code and when we check that back to the GitHub, normally what we do is when we do this, we do a pull request, like so. When we do some changes, and now we have to merge the code. This is for mostly for the developers; they will understand. So we have to merge the code with the we have to merge the code with the main branch or any other branch. Normally we raise a pull request, and when we raise a pull request, we assign that to our peer reviewer. Somebody reviews that, and then they will say that okay, you have to change this, or it's all good. Now you just have to do the check-in, and the GitHub Copilot does everything for us. It creates a pull request, it reviews the code, and then it gives us like what can be modified, right? And then we just have to just check, validate it, and then accept all the changes, and done. That's it. It creates everything else. So this is the code AI that is coming into uh, existence now. So yeah, developers, like very soon, I think we'll have all the developers will have to see how we will be able to use this more, right? Yes.
So, Aslam, if we can go to the Copilot, sorry, again, VS Code. So, what all the plugins do we need to install to make that as an AI-based plugin, or is it like I have not used it a while. So, is it like should we install GitHub Copilot, or is it we have to do separate Chat GPT, or how is it? What
No.
is this?
Yeah. So first with this cursor AI, a lot of the things are already coming in, right? But still, I think for GitHub, you will just have they have these extensions. We'll have to add those extensions. So you have here extensions, right? So here, if you see, so GitHub pull request or GitHub Actions. So you have to install these extensions, and then it will work, and then you will be able to use those actions.
Okay, so in this demo, right, whatever you showed, it created a project structure, right? Is it possible to generate the whole project structure and code along with it, or is it like it will just give you the structure and we have to insert the code in each of the file?
No. It will. You can insert. You can also say that you have to. You generate a. You say okay, generate a code and insert it on. I think. Oh, sorry. We can insert the code. If we say. See. Are you able
Yeah.
to see?
Yes. Yeah. Perfect. Okay.
So it does. You, it's yeah. I mean, sometimes it's scary being a developer. Like it does something, does a lot of things there.
Yeah. So, Aslam, in that case, if this can do everything, what all things as a developer or as a end user, how should we, does it do also generate a test cases for this?
Yes, can
Okay.
generate these cases. It can do end to end. Yeah, like it can add code, and then it can also check into your GitHub. It can create all the pipelines if you want. It does like from end to end.
Okay.
But that's it. So the when we say this AI ethics, it's just that there should be somebody to monitor this, right? Because if it has hallucinates, then there's no way to know. Right? So there should be somebody who needs to monitor what it does.
Okay. Is there any limitation in this which the developer needs to be aware of?
There might be limitations. Limitation maybe by the need for us, right? For example, if I have to develop something, if I have to solve an issue based on design pattern, and then I can write for example, use generate a code for me for this scenario and use a publish subscribe pattern, right? But if this doesn't identify that, then it might not be able to write it properly, right? So those are some of the things that we have to be aware of.
Okay.
But mostly it should write like 90% it will write like it is. I've tried like it is giving very good design pattern solutions for problems. So uh, very soon it will be like 99%.
Okay. Thanks, Aslam. Sorry.
So this is from the coding perspective, what all we can do. And we have like content creation, coding assistance, right? So here the comparison between the machine learning, deep learning, and generative AI. So we have like code function. So machine learning, it is using to predict and classify. Deep learning is perceive and understand. Generative AI is create and generate, right? It is generating and creating contents. Input for machine learning, it's structured table. Like as I said, like rows and columns, right? Where we have to say like properties of certain like flower, we have all the properties as features and then the label. So those are in tables. Deep learning is images. As I said, like convolution neural network, it identifies the 4 images. How it identifies? It breaks our images like into pixels. It identifies the edges, the corners, and based on that, it is able to identify our other photos as well as it keeps on learning, right? Generative AI, how they work is like prompts. You prompt a generative AI. The prompt might be text or image. And algorithm used, statistical models. For machine learning, we have SVM, we have Naive Bayes. So there are a lot of like linear regression. There are a lot of machine learning algorithm. For deep learning, we have neural networks, as I said, like the convolution transformers, RNN. Generative AI still uses transformers. So it uses transformers in order to get in order to generate the content. So example, we have, yeah. Is there a question?
Aslam bhai, Razak here. I have a quick question in terms of linear regression analysis you mentioned. Like, what exactly goal of linear regression here? What are we trying to achieve using that?
Sorry, what is that? Can you come again?
So you mentioned about linear regression, right?
Yeah.
So what exactly are we using linear regressions?
So as you said, for machine learning, there are two types. One is classification and one is regression. Regression is used for analyzing all continuous values. Continuous values in the sense time series data, right? So for example, I have my stock prices. So from the stock prices, it will learn about how the stock prices were there previously, and then it will predict what is the stock price for the next day. So that's called the regression. So that's regression, but not a linear regression. So linear regression
Okay.
is something that falls on a straight line. So I will give you an example of that. Give me a sec. I'll give you an
Okay.
example of that. So, okay, maybe I'll tell you that.
The reason why I asked you is I've used linear regression, but in a different context. So I was just trying to connect how we're using it in here.
Yeah, so give me a sec. Let me stop sharing for a sec. I just have to take that other picture. Give me a sec.
No problem.
Just a minute.
No problem. Please take your time.
I'm not able to find it. Okay. I'm trying to find a picture, but I'm not able to get that. So, how it
Aslam, I
works?
can connect with you after the call, and then you can let me know. We can
Yeah,
talk about it. That's okay.
yeah. So, for example, how it works? So imagine a graph. Okay, we have x-axis and y-axis, right?
Right. Yeah. Yeah.
Now, what happens is, so this x-axis is in we say the stock prices.
Right.
Okay.
Okay.
Y-axis is stock prices, and x-axis is the day, like the year, 21, 22, 5. Okay. Now I'm trying to analyze Apple stock. Okay. So when I analyze an Apple stock, the points, the plot, it might go up and down, right? Dollars might go up and down based on the years, right? Now, so it cannot be a straight line. So when I say straight line so when I plot the points for between the year and the dollar, so for each time there will be an increase and then decrease. If it is a complete increase, I can get a straight line, right? From the x-axis, it will just go. It will just go in a steep angle.
Aslam, you're sharing the screen?
No, not yet. Sorry. But I don't have that picture. Give me a sec.
Okay, no problem. I was wondering that because we are not seeing your screen, so maybe you're sharing something. That's okay. You can continue with your question.
Yeah. So the way that it is getting plotted, or maybe I will just show here. Oh, give me a second. Let me try to show here. So I have something called, I have just created a sample model for this stock prediction. I'm trying to predict the Apple stock using an algorithm called SVR. Here, what I'm doing is, so this is my, so this is the code that I've written. So here, what I'm using, so there is an algorithm called support vector regression. It's called support vector regression. It is used for analyzing the time series data. When you say time series, it's stock. So if I say stock, if I have to predict it based on the previous behavior, if I want to predict what is going to be the next day, right? So I've used a model and then I tried to build it here. So if I say I have to go one level above. The values, inference. So this is actually for training the model. So I've used very less data. So what happens is this is getting trained with my CPU itself, right? Because I'm using less data. So if I say it should bring up an inference UI. So slow. It says get next step prediction. So when I say next step, yeah.
Okay.
So it gives me a value here. If you see $238.81, but this is very off with the data that with the current data, right? The current data, I think it's around 270 or something. Why this is coming here is because I'm training this with less data because it's it's in my CPU, right? But I have another thing called So this one. So this is another inference, SVR model inference. So this is another inference that I have written. So if I say, close this one. If I see this, so here what I've done is, so there's something called Hugging Face. Maybe I can do one more session on those things. So this Hugging Face is kind of a place where you can develop your model and store it there. And whoever needs that, they can just download it from Hugging Face and use that model. So here again it says 238, right? Because what we are using is, even though we are using more data, but still we are using what we are using is, we are using a ML model. We are using a ML model. Okay, so this is the stock price. We are using a ML model. So either I used the same ML model, one with less data, one with more data, but both returned similar data. Now I have another inference point here. This I used this one, deep learning, in order to train and get the result. Okay, so this, if I say, so if I run this, so this, if you see, it is identifying, if it's identifying pretty much close to what current. So currently it is around 272, but it is pretty much coming to 267. Meaning that I just have to fine tune some more so I just need to increase my number of nodes here, right? More, and then I might hit like 100% result. But this is very close. So this is the difference where we see the machine language and then where we see the deep learning, because deep learning is able to do lots of more iterations than what the machine learning does, right? And so it gives me more accurate answer here. So coming to your thing, if I have to explain it just by words, right? So if you have this x-axis and y-axis,
right? Yeah.
If you're going to, sorry, what's that?
Oh, yeah, I'm just listening to you. Yeah.
Yeah. So if you are plotting these points between the y-axis and x-axis, what the model will try to do is it will try to get a straight line, meaning, so for some points might fall on that straight line, some points will fall out, I mean, they won't be on the straight line. So for example, if I say, if I'm seeing the Apple stock, right? So the Apple stock steadily increases. There's no, we'll talk of an ideal situation. So the Apple stock steadily increases. Then it is a regression, like you can plot it with a simple straight line, right? But now, if there is some kind of deviation, like there is some kind of dip in some month and then it increases and then decreases, in that case, there is a small deviation. Now, if the deviation is standard, like if I'm plotting 10 points and out of that, like 6 points, we have this deviation, then the plotting curve, I mean, the algorithm will plot the line according to that, right? It will take in account of all those deviations. But there are certain times where there may be some rare condition because of which it would have plunged very low just for 1 month, right? But and then it moves on steadily. Now, this data that when it plunged down very low, that's called an outlier. If we are going to predict using that value, then our total prediction will be wrong because that is a one-off case. So the system should know that, the algorithm should know that it can just leave out that, it shouldn't consider that, it should just consider all the other points in order to get a proper result, right? So that's the linear regression goes.
Thank you, Aslam. Yeah, that's helpful, really helpful. Thank you.
Does that answer your question?
Yes,
Bharat?
yes, it does. Yes.
Okay. Are there any other questions?
There are no questions as yet, Aslam bhai. Anybody has any question, please unmute and ask the question. Feel free to ask the question.
Either the session was too good or it was too bad.
No, it was fun. I think it was very good. There's a lot of the learning was done in this one. And even Razak bhai was very much into it.
Actually,
And
I can, yeah, we should do one more, like, especially for complete thing for LLM and agents. There are a lot. I thought I could cover most of so, but when I started preparing the slides, like, it was, if I have put everything, it looked too overwhelming. So, because
yes,
that has its own, that's its own ocean, right? The LLMs and how that works.
absolutely. Numan has a question. Ji
Yes, ma'am.
Numan bhai, you can unmute yourself.
Aslam, thanks for everything that you have shared. Appreciate it. I have a general question and nothing technical. My profession is supply chain management,
Mhm.
and for someone like me or any other profession for that matter who are not very technical, deep into artificial intelligence and stuff, what pathway, what course of action will you suggest to upskill ourselves to kind of stay abreast with the development happening in this particular field that is benefiting many others?
Yeah. So from your perspective, no one by, like, you would have to, because I see a lot of this supply chain softwares, third-party softwares now coming up with agentic AI. So from your perspective, what you'll have to know is uh, how this works, like on a very high level, what is an agentic AI and how it works, and then the governance part of it, like how secure it is, right, and how this data, whether this data, whatever they are, is confidentially published. So something on the governance side. So on a very high level, what is an agentic AI? On very high level, how that works, and then on a very high level, like what is the governance part of the agentic AI?
Thanks, appreciate it. Possibly I'll connect offline with you to devise a bit of a pathway for myself to start or to get to know the starting point for myself. But yeah,
Yeah,
appreciate it.
so yeah, I
Thanks.
can send you something like Microsoft has a lot of these free courses for in order to start, right? I can send you some links. I should have added this here, but I will send you that.
That'd be great. Thanks.
Yes, Aslam bhai, I think that sharing the links in the in our CMSS professional group would be fantastic. I'm sure that you're part of that. If you are
Yeah.
not, you just let us know, and we send us and we can share it there as well. But this will be very helpful. So we have a couple of questions. I'll go, Kashif bhai, you have something? You raised your hand.
Thank you, Aslam, for your time and arranging this useful and important session. which is very in the market right now, and everyone is curious about how to use the AI software and how we can upgrade our skills as well. I have a question. If you could share the list of the apps that we can use for the AI, like different apps, a music app, a music AI app, or chatting app, or any other app that we can improve our skills, like a photo generic apps. If you could share the free apps and the paid apps, that would be great for the audience.
Okay, I'll have to check, Ashok bhai. I'll check and I'll share that.
Okay,
Said
thank you.
bhai,
Yeah. So, Aslam, regarding this agentic AI, so is there any prerequisite or prerequisite when to use agentic AI or when not to use agentic AI? Is it something, what are the material you're sharing? If it has, then I'll go through that material, Aslam bhai.
Yeah. So I haven't put anything on I haven't put anything on agentic AI. That's what I said. Like I can take one more session on that one. So for to your question, like when we want to use agentic AI, right? Currently, the path is going towards agentic AI. So with even in my what we are doing as well, we are moving towards agentic AI. So all like previously, it was like we started with the agents, right? So people we developed agents so that people can ask question. For example, we have like we are doing now the enterprise search with agents. So the people can go and ask questions to the agent, and it will pull them the result. Now what we are doing is we are going towards this agentic AI. So previously we have different agents, right? One for human resource capital, one agent for finance, right? Now what we are doing is we are going one agent, right? And that agent, it's like an orchestrated agent, and that agent will talk to different sub-agents. So that's the agentic AI, right? And that agent will start reasoning out the answers and give us the best answer, right? So that's what is agentic AI. So there's no specific condition now where we are going to go for agentic AI. Like agentic AI can be put into all the requirements now, but it just needs to be robust, right? Like you develop one orchestrator agent and then you have multiple sub agents, and now you can it becomes kind of a good design patterns wherein you are not dependent on a single agent, right? Like whenever you need a new agent, you create that agent and you add that to the orchestra agent.
Thanks, Aslam bhai. Thank you.
Aslam bhai, there will be some question. People are looking for some recording of this thing. So what I'm telling them that we do not have we did not record this event because of some privacy concerns. But I'm inviting everyone to join the professional CMSS professional group, and we will be able to they will be able to ask some question over there, and we will be able to get back to you, and then we will go. And I'm actually inclined, I'm just thinking that we may be able to have another session, and that session I think we'll have to focus on the questions what we receive, and then we can structure your presentation on that one. We will review that thing with our team, and we go from there. And as regards the people who wanted to join our professional group, WhatsApp group, I will be sharing, or if you can share your telephone number, or if you can give us a contact somewhere or contact us somewhere, I'll share my telephone number, and then you can send me your text, and I can share the link. Or Razak bhai, if you can share the professional group link here.
Sure, I'll do it in a minute. Yeah.
Okay then.
Okay.
You can continue, Aslam bhai.
That's it. That's all
Okay,
I had.
okay.
Maybe like we can have one more session for just for
Yeah,
the
we
AI.
will. I think we will have to have a one more session because this was there was too much of things which cannot be covered in one session. We need to go a little bit a step more on this one, right?
Yeah.
Because your was quite structured one for the ones with have a little bit of background, and there are quite a few who are little bit novel to this AI, and they wanted to look into the front end, and then they have to go into the back end.
Yeah, yeah, exactly. So this is the Hugging Face interface. So what it does is it has so there are all the models are published here. Like people develop open source models are published here. So if you want to try anything, like you can go download the model. Only thing is you might have to have this your CPU or the GPU more, but other way of working towards that is you can still download it and you can use Google Colab. So Google Colab, in Google Colab, what you can do is you can, let me just show you that quickly. So in Google Colab, you can write the Python code. For example, you download something uh, from you download something from your this thing, and then you could, if you want, you can also write your code here. Like if you want to train the data, you can write your code on the Google Colab, and then here you could choose the runtime. I think it has CPU, GPU, and TPU. The TPU is kind of paid. You get like for 90 days, you can pay $13. Or you can also pay that for monthly pay as you go, or there's a subscription. You can use that, and then you can train models with huge data. For example, here I trained a model, so I'm taking data from 1970 till 2018, which is a huge set of data. And also what I'm doing is it's not only that, I'm also creating my own feature set here, right? When you saw this machine learning, when I predicted the price for stock price, this one, the ANN, the one that I created using ANN, it gave me around like close to 95% closeness of the result, right? It was like, it is 272, but it gave 268. But for that, there are two reasons. One is it's the number, it's deep learning, and the other one is I'm using large amount of data to train, and then also I'm building the features, right? I'm building some features uh, individually. I'm building from some features. So this is where we will come into play. So now, for example, this everybody can build this one, right? Like you can go and use, because the algorithm is just one line of algorithm, because it's all available with Python libraries. So it's one kind of algorithm. But how the data, input data, how you give, so that you can put some more intelligence, and then your answer will be more effective. Like I can also develop the same thing, and you can also develop model to solve the same problem. You will be more effective based on how you are thinking out of the box and adding inputs to that, right? When you do that, like even though we solve the same problem, your solution will be much better.
Yeah, and Aslam bhai, I think you have got a wealth of information, and in this short time, we will not be able to capture each and everything. But I think we do need to have something else, another session, since already we are 15 minutes above. I would like to thank you very much. I have no words to thank you for the wealth of information you have shared today. And we will be looking forward to another session which will be focused on what we have learned so far and to make it from there. And we will also include the people who are a little bit newer in this world and the AI and how to use it to better equip themselves in their current scenario. And let's plan that, and then we will have it another one for today. I feel that people have some other commitment and they are leaving, so let's conclude it. Let's call it a day for today, and we go from there. Siri bhai, Razak bhai, would you like to say something, or anybody else would like to say something? Please feel
Yeah,
free. So,
I would like to say that thanks to all the task force team members, which will be you on the lead, Nadeem Bhai, Siri, Razak Bhai, and Aslam Bhai for arranging this wonderful event. And we had a very good attendance today for this event. So thank you so much again, and hopefully we will again next session within 2 weeks to 3 weeks. So please coordinate each other. Thank you so much.
thank you, Kashyap bhai, for your kind words. Incidentally, Siri bhai has introduced Kashyap bhai as my co-founder, whereas I think Kashif Bhai is the lead member in this founding this CMS, and his dedication actually took CMS to this level that we now are Canada wide and we are widely acknowledged for our work, whatever we are doing. Kashif Bhai has been recently awarded with many certificates as well. And yes, Masood, we are definitely looking for, thank you very much for liking and coming today, but we are definitely looking for a next session. Stay tuned. And I thank everyone who participated today, and especially my organizing team. Siri bhai, you were marvelous and you're welcome. And in your organizing all this event, Razak bhai spreading the news and everyone who else has joined, Haris Bhai and Noman Bhai, Talal Bhai, Ijaz Bhai, thank you so much for joining. And over to you, Siri. I think you have to conclude.
I just want to say thank you. Not thanks for everybody. Hopefully, you guys had something. You learned something. Hopefully, I did not waste your time. Precious Sunday
No,
time.
we learned a
But
lot,
thanks for
Aslam
coming.
Bhai. We are so grateful and obliged that you have spent that much of time with us, and we are definitely indebted to you. And I will be touching base with you shortly with my team as well. So.
Sure, sure, Nadeem.
So Siri bhai actually he is unable to mute himself, so I I speak on his behalf that he's thanking everyone for joining and for organizing this thing, and he's especially Aslam bhai that for giving us such wealth of information, and we will be we will be in touch with all of you again. Meanwhile, if anybody have any question, please feel free to unmute and ask. Otherwise, we will just say thank you very much and have a very good night, everyone. We wish you all the best for your future endeavor and future learning for AI, which is certainly a futuristic approach which everybody must take. And Asram bhai, I will be in touch with you for the next session so that we can
Inshallah.
structure it in such a way that and we will try to find a timeline where we can have maximum attendance as well as more time to cover each and everything. Thank you very much, Siri bhai, Razak bhai, Numan bhai, Kashif bhai, everyone who has joined. And Tapas bhai, actually, he left and he was with us for a long time. Sayyid Riaz bhai, your questions were very to the point, and that helped us to learn as well. SA, as Sabah said, I think were you able to join the link or not yet? Otherwise, I have sent my telephone
Assalamualaikum.
number.
Yes, I'm able to join it.
Okay, when you will join there, we will be definitely giving you our the question and answers what you want. Aslam bhai is there and he will be able to answer it there as well, or we will have another session. Thanks very much for joining.
Thank
It
you.
seems like Aslam bhai, no other questions are there. I again thank you very much, and everyone, you have a wonderful night. Happy
Thank you.
learning.
Thank you.
Thank you.
Good night. Good night, guys.
Bye.